Let's take a look here. This is the rest of Unit 1, 1.5 and 1.6 actually. So we're taking a look at the graphs of these trig functions. We're going to spend a good week and a half looking at these graphs, take them apart, and kind of put them back together as we go. Here's the sections, so 1.5a, 1.5b, 1.6a, and 1.6b. We're going to break these down even within each one of these sections to go a little bit farther with this. So let's take a look here. Let's start with the sine graph here and the cosine graph, just kind of taking a look at the general shape. This is called a parent function. So if you think back to what we were talking about before with absolute values and being a V shape and quadratics being a U shape and things like that, this is really kind of the same thing. So the sine graph, the basic sine graph is always going to look like this. And the parent function is y equals sine x. Now let's make a connection here. This graph is going to come right from the unit circle. So when I look at the unit circle, there were some key things that we had on here. And so let's take a look at them. We've got 0 here, either in 0 degrees or 0 radians. And I had a sine value of 0. Okay, the sine of theta is 0. Well, on the graph, that's going to be the same thing. It's going to show exactly the same thing. So 0 on the graph is here at the origin, and it's going to have a value of 0. Okay, it's going to be at 0, 0. When I go to the graph, another key point on here would be up here at 90 degrees, except we're going to use the radians portion of that, which is pi over 2. And the sine value at pi over 2 is equal to 1. So I'm going to go here. I'm going to make a spot where pi over 2 would be, and we're going to label it pi over 2. And at pi over 2, this graph is going to be up at 1. Okay, so I have that point there. Go back to the unit circle. Another key point was over here at pi. Over here at pi, the sine value was back at 0 again. So I'm going to go back to my graph. I go the same distance because pi over 2 is halfway between 0 and pi. I'm back at 0 again. Go to the unit circle. I've got at 3 pi over 2 down here. The sine value actually is negative 1. So I want to go back here. I go the same distance. I've got 3 pi over 2. The sine value, let me move this over a little bit. 3 pi over 2. The sine value is down here at negative 1. Then I finish off the unit circle. I finish off one revolution around the circle, and I get over here at 2 pi. Well, the sine value is still 0 at 2 pi, and so I'm going to go back here, and at 2 pi, I'm back at 0 again. Okay, that's one revolution of the sine graph. It goes all the way around the circle one time. And if I write that on a graph, I'm going to call that the period. Okay, and how many times does it happen, or how many graphs are shown in here? This is one regular sine graph. So it goes up, comes back down, goes all the way down, and comes back up. That's one period of sine. The period of sine is 2 pi then. Okay, that's one period of sine. Now this graph continues. If I were to go around the circle in the other direction, if I were to go, let's say over here to negative pi over 2, at negative pi over 2, I'm going back to this graph, negative pi over 2 from the unit circle again. Negative pi over 2 is going this way, but I end up here at negative 1. And so I end up doing the same exact thing, and the graph ends up being down here. And then I go over here. If I went to negative pi, my graph would be back at 0. Okay, and my graph continues forever in that direction. Just how many times I go around the circle, which direction, and so on. If I continued going around the circle more times this way, I'd go 2 pi, I'd go an extra pi over 2, I'd go to that back to that 90 degrees. 2 pi plus pi over 2, okay, making a common denominator gets me at 5 pi over 2. At 5 pi over 2, this is going to be back up here at 1. And then I'm going to go another pi over 2 to get at 6 pi over 2, but that's actually 3 pi. It reduces. I'm back down here at 0. Okay, and this is going to go on forever. Okay, and so I can continue making that sector, but the parent graph of sine starts at the origin, goes up at pi over 2 to 1, goes to back down to 0 at pi, goes down to -1 at pi over 2, 3 pi over 2, this should be, not pi over 2. Looks like I kind of missed a 3 there, 3 pi over 2, and then back up to 0 at 2 pi. That's a 1 period of sine. And so when I come down here and I kind of talk about what happens here with the period, not that one to the right here, the period of sine, I get one full sine graph in 2 pi one time around the circle. The amplitude, you can see how high the graph goes. Okay, this area right here, from here to here, is called the amplitude. Okay, and so we're going to label that A. So the amplitude is equal to 1. The amplitude is 1. Ultimately, an amplitude is defined or can be found as half the distance between the minimum and maximum point. So half the distance from here to here, from -1 to 1, I have a distance of 2. Okay, from -1 to 1, I have a distance of 2, and then half of that distance would be 1. So the regular sine graph has an amplitude of 1. The minimum, clearly we can see this is at the minimum here at 3 pi over 2. It's also at, if we kept going with this graph, it's also at 7 pi over 2. If we kept going to the left with this graph, it's also at -pi over 2. Okay, and so the first one, though, the first minimum that happens in the positive between 0 and 360 is at 3 pi over 2. And it's actually at 3 pi over 2 comma -1. That's the minimum point. The maximum happens at pi over 2. And again, the ordered pair there is pi over 2 comma 1. Okay, it's at the maximum point. I have INT here. INT is going to stand for intercepts. So I've got intercepts here at these points. So I've got intercepts at 0, comma 0. I've got intercepts at pi, comma 0. I've got an intercept at 2 pi, comma 0. Okay, and those are all the ones between 0 and 360. The maximum was at pi over 2. That's the only one between 0 and 360. The minimum at 3 pi over 2, and so on. Okay, so then let's take a look at the cosine parent function, y equals cosine x. And again, I'm going to be looking at these common points. So at 0, I've got a cosine value of 1. Ooh, here's the cosine value. Okay, so I've got a cosine value of theta at 1. And so I want to say at 0, I'm actually up here at 1. So my cosine value is at 1 at 0. And then I'm going to look at those same exact points. I'm going to look at pi over 2. I'm going to look at pi. I'm going to look at 3 pi over 2. And then I'm going to finish off looking at 2 pi here. Okay, so I go back to the unit circle. At pi over 2, I've got a cosine value of 0. And so pi over 2 has a cosine value of 0. At pi, I've got a cosine value of -1. Smartboard's off. At pi, I've got a cosine value of -1. At 3 pi over 2, I've got a cosine value back up at 0. And then hopefully you can kind of imagine or kind of see what's going on here. At 2 pi, I'm back at the same exact cosine value that I started at. And so then that's one period of cosine. I can draw the graph in here. Looks like this. One period of cosine looks like this. Again, it goes from 0 to 2 pi. So when I look at period here, I've got a period of 2 pi. And one period happens between that. The same idea happens though, is that if I were to continue this graph to the left-hand side and I were to look at negative pi over 2 over here, that would be going on the unit circle, would be going this way. At negative pi over 2, I'm still at a cosine value of 0. And then if I went over here to negative pi, I'd be down here at negative 1. And so this graph ends up looking something like that on the left-hand side. If I kept going this way, I would be at 5 pi over 2 here. That graph comes back to 0. And then again over here at 6 pi over 2, which is 3 pi, my graph comes back down to negative 1. Okay, so I end up with the graph that looks like that. But the original cosine parent function with one period is between 0 and 2 pi, one time around the circle. Again, you can see, hopefully, that the amplitude is still 1. Okay, it only goes from 1 to negative 1, doesn't go any lower or higher than that. Okay, so make sure that that you're aware of that. The minimum points, again, there's many of them, but the first minimum happens here at pi. And so the ordered pair is pi comma negative 1. The maximum point happens here at 0 and here at 2 pi. So I end up with 0 comma 1 and 2 pi comma 1. Okay, happens at both of those points. And then I have these intervals, intersections rather, with the x-axis at these points. So I've got pi over 2 comma 0, pi over 2 comma 0, pi over 2 comma 0. And then I've got one at 3 pi over 2 comma 0. And again, they're coming from the unit circle. These are places on the unit circle. At 3 pi over 2, the cosine value is 0. Okay, we're looking just at the cosine graph. And then I've got 5 pi over 2 comma 0 as well. 5 pi over 2, I guess, is past 2 pi, so I don't necessarily want that one. I only want the pi over 2 and 3 pi over 2. So when I look at this, I can take that parent function and I can change it. I can do some other things to it, like put a number out in front. I can put a number inside with the x that I'm doing some multiplying with. And so if I put a number out in front, that's going to affect my amplitude. Okay, so if I put a 2 there, then my amplitude is going to be 2. Right? In this graph, in the first graph that we were looking at, we have a 1 there. So if I know that number in front of the cosine or that number in front of the sine is the amplitude, how high it goes, then I can look at it and I can just pull that out, and I can use a quicker method here in graphing instead of plugging in these numbers. By the way, you could plug these numbers in. You could create an XY chart if you wanted to. You can always create an XY chart, except your x's are going to follow along the unit circle. They're going to follow along in radians along the unit circle. And then your y values are going to come back once you plug them into the function. So the cosine of 0 is 1, cosine of pi over 2 is 0, the cosine of pi is negative 1, and so on. Okay, so you could do that on your calculator, and that would be fine too. Okay, the amplitude is affected by that number that's out in front, though. And so then the period is affected by the number that's multiplied times the x. And so I can find out the period by taking 2 pi, which is the original period, and dividing it into, well, whatever parts it's being divided into. So the original one is being divided by 1, because I, again, have a lazy 1 here with this x. Okay, so it would be 2 pi divided by 1, which is just 2 pi. Okay, so hopefully no issues there. Okay, so let's take a look at some ideas with this amplitude and period. I put this because there's a worksheet in the back, so go ahead and grab that worksheet on amplitude. You're just determining, well, if the graph has a parent function of sine or cosine, then determine the amplitude and period. And here's the examples that go along with that. So the amplitude is the first thing that we're going to find, because it's the first thing that comes in the equation. So I've got an amplitude that's equal to the number in front of the function. So I'm going to put that a is equal to 2. It's the absolute value of 2, which is just 2. I'm then going to name the parent function. So I want to know what this looks like. So it goes up and down. Okay, it just depends on whether it's a sine or a cosine. Does it start up or does it start at the origin? Okay, and so I want to take a look at this, and I want to name the parent, and the parent function is a sine function. Okay, and if you want to put an x there instead of theta, that's fine. Sine of x is fine. Then the last thing that I want to name is I want to name the period. Well, the normal period of amplitude or sine functions is 2 pi, except that if there's a number in front of the x, it's going to be something else is going to happen to it. And so then we're going to talk about what that looks like on the graph, but first we need to be able to pull that out. And so my period is going to be 2 pi over 3, because the number in front of the x value was a 3. So then part B, I've got the amplitude is the absolute value of -3, which is 3, so it goes up 3 and down 3. The parent function is cosine of x, and then my period is equal to 2 pi divided by the number that's in front of the x. Well, the number in front of the x is a 1/4. So I'm going to divide that by 1/4. Well, taking 2 pi and dividing it by 1/4, again, we will do a lot of these things. If I write it like this, some of you remember what happens. I end up with 2 pi times 4 over 1, which actually ends up at 8 pi. So one period, one revolution around this graph from beginning to end happens in 8 pi. Okay, which means that again, if you think about it, instead of it happening in 2 pi, it's actually happening in 8 pi, so that graph is extremely stretched out. Okay, and we'll talk about all the other points that affects along the way in the next video. So then the next one here, we've got an amplitude. There's a -1 in front of the cosine. The parent, I just named it, is cosine of x. And then the period is equal to 2 pi divided by the number that's in front of the x is 2 pi over 5. So again, 2 pi divided by 2 pi over 5. I flip the second one over and change it to multiplying because I don't have much room here. I'm going to do that. So the 2 pi's are going to cancel, and I get a period of 5. So it happens in a period of 5. So it goes from 0 to 5. This graph happens more than once, or only one time. Just let me get some extra room here, and then let's do the last one here. So we want the amplitude is equal to absolute value of the number in front, which is 1/4. The parent function is sine x. I want to put theta. If I put theta instead of x, you can substitute those two. And then the period on this is equal to 2 pi divided by the number in front of the x, which is a pi. And 2 pi divided by pi is just 2. And again, we'll look at how those things actually affect the graph at a later time. Okay? This last part is just kind of comparing. Okay, so we'll take a quick look at comparing. If I've got sine of x and negative sine of 2x, the two things that I'm looking at are the period and the amplitude. In the first graph, the period is going to be 2 pi because it doesn't have any number in front of the x. So f of x period is 2 pi, and then g of x, the period is 2 pi divided by 2, which is just pi. Okay, so we're just looking at comparing those things. The amplitude of the first one is just 1. The number in front of the sine is a 1. And the amplitude for the second one is the absolute value of -1, which is the same. So it has a different period the first one happens one time in 2 pi. The second one happens one time in only pi. So it's a little bit more scrunched together. And we'll take a look at those graphs again after we're done with this. So the first one, or the second one here for B, we're looking at f of x. The period is equal to 2 pi divided by 3. For g of x, the period is also 2 pi divided by 3. Okay. I've got the number in front of the x as a 3, so I'm going to divide 2 pi by that to figure that out. The second part, for f of x, the amplitude is the number in front of the cosine, which is a 1. And for g of x, the amplitude is the number in front of the x with absolute value, or in front of the function. So negative 4, absolute value of negative 4 is 4. And so this graph is going to be taller. G of x is going to be taller than f of x. They're going to have the same period, so the graphs are going to look the same, except that one's going to be taller than the other one. So we'll again take a look at those graphs here in the next video.